Okay, you're welcome to today's class. Today we want to look at the architecture of data in memory. The last previous classes we've done standard terminologies of DSA, right? And we have also seen data objects, we have seen data type. So, however, knowing what data is and how to process it is not enough. A computer system must know how to organize this data, yeah, for efficient access. So this is where data structure comes in. So what is data structure? Data structure is a method of storing and organizing data so that it can be accessed, processed, and managed efficiently. That is the simple definition of what data structure. So what data structure actually means is that it's telling you how data lives inside what? The memory. Don't forget, when you are sleeping, you are existing somewhere. Then when you wake up, you are loaded into your body, and then you wake up and you exist in the world. Same thing happens to what? To the computer. There is the hard drive, there is the memory, right? So when you put on your computer system, things are copied from the hard drive into the memory. So I have defined data structure. Now, in this class, I am also going to tell you the difference between data type and data structure. Students often confuse themselves with these two terminologies. The last class, I told you that data type has to do with what? Data types divided into what? Uh, built, built in and what? Derived, right? And then I gave you an example of these as what? Integer, right? Float and char, example. Then I gave you an example of these as what? Array, right? Um, List, then stack, and then queue. Example, I'm just giving you few. I did that. Okay. In this class, I am going to tell you the difference between these. Data type. Now, you have to look at two perspectives. If you are looking at the perspective of a programming language, then this is okay. You can classify this as what? Derived data type. But when you're actually looking at it from the perspective of DSA, data structure and algorithm, this is more of what? Data structure than a data type. Because data structure basically has to do with what? Organization of data in the memory. And that is what this is all about. But one guy that seems to have leg in both sides is what? Array. So in whichever perspective you are looking at it, an array can be classified as what? Data type and as what? Data structure. But when you look at stack, which is actually gotten from what? Array and list or list, right? Then you are basically or purely looking at what? Data structure. So data type through the perspective of DSA, which is data structure and algorithm, data type is the nature of the data, while data structure is the organization of the data in the memory, right? So this is what? Data structure. And I've defined data structure for you. So let's go further. So this data structure is classified into two, and that is what? Uh, Linear and what? Non-linear data structure. Now, this linear data structure, this is where you arrange data sequentially, right? So you are going from 10, 20, 30, 40, right? Like that in a straight line, like an X state, house arranged in a straight line. So that is linear data structure. Now, this linear data structure is further divided into two, which is what? Um, Static and what? Dynamic. So we have static linear data structure and dynamic linear data structure. Then non-linear data structure. So example of this static linear data structure, you are looking at what? Array, right? Now, why is it static? The memory is fixed And memory is usually allocated at before execution time. So if I'm allocating memory, say in numbers, this is an array, and I say 10. So what I'm simply saying is I'm going to allocate memory for 10 integers. So an integer is what? 4 bytes. So 4 times 10, that will be what? 40 bytes. So 40 bytes of memory space will be allocated before runtime. If I now supply only 5, that will be what? 20 bytes. The remaining 20 bytes will be wasted. You cannot automatically stream. So that is the disadvantage of what? Static. But memory is allocated before runtime. So that is what this one is, right? Why this one is dynamic? So example of this dynamic, we are looking at linked list. We are looking at stack. We are looking at queue, right? So example of dynamic data structure is what? This. Now, in this one, memory is allocated at runtime, and the memory can automatically increase or decrease depending on how much memory we need. So that is what this dynamic is all about. Then we have the non-linear data structure. So in this one, data are arranged in hierarchical manner or network. So hierarchically or network. So example of this is what? Tree, right? Map, graph. So these are the example of data structure that you can classify under what? Non-linear. So like this tree, you're having like CEO of a company. Then it comes to what? Manager, right? And then this manager is looking at staff 1 and then staff 2, right? So you're having something like A, then B, C. So this will go to D, E, right? F. So in a tree-like manner. So that is what this nonlinear is. It's not a straight line path. Then you're looking at the graph, which purely has to do with networking. Example of that is your what? Your Facebook friends. Facebook friends, one node can be connected to what? Multiple nodes. So you connect to one friend, and then that one friend, you have suggestion of other friends for you. So that is the concept of a nonlinear data structure, how they are arranged, right? So that is what I want to show you in this class, looking at the architect of what? Data structure in the memory. So in the next class, we are now going to look at the individual data structures: array, linked list, stack, queue, tree, map, graph, and many more data structures. So I want you to just see how they are classified. Looking at data structure, linear, non-linear, then linear is divided into static and dynamic. For static, memory is allocated before execution, while at dynamic, memory is allocated at runtime, so it can increase or decrease. While this one, memory is fixed. So you are seeing how the allocation is being made inside the memory. Then you look at linear. It's not a straight path, right? Hierarchical or networking or network structure. That is basically what this nonlinear is all about. So we are going to see all of them individually. So what I have done to you now is to show you the basic foundation of intro into what? Data structure. Now we will go into learning each of them one by one and how you use a programming language to write them. I'll probably use C language, right? So that is what this class is all about. If you have come with me this far, don't forget to give me a thumbs up. And if you have not subscribed to my channel, please do so. And you can also follow me on my Facebook page. So till we see in the next class. Bye-bye.